Hello friends, today we're going to be looking at square root, which is LeetCode problem 69. Given a non-negative integer x, compute and return the square root of x. Since the return type is an integer, the decimal digits are truncated, and only the integer part of the result is returned. And then they got some disclaimers here. You are not allowed to use any built-in exponent function or operators such as power, blah, 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 niner. Okay. Example 1. Input is 4, so the output is 2. 2 times 2 is 4. In example 2, input is 8, so the output is actually 2, because the actual value is 2.82842, but because it's an integer, it's going to truncate it down, so the answer will be 2. Let's see how to do this. Okay, so to do this, we're going to do a binary search. And a binary search basically halves the array each time you go through it. So in this case, L is index 0 and right is index 6. And then we take 6 plus 0 divided by 2, so the midpoint is index 3. Our target number we're looking for is 6. So because 6 is greater than 4, meaning it's greater than the midpoint, we've got to shift the left over to the mid plus 1. So L becomes 4, 0, 1, 2, 3. The midpoint is 3, 3 plus 1 is 4. The right stays at 6, 6 plus 4 is 10, divided by 2 is 5. So these retain their indices, so this is 4, 5, and 6. Now, 7, the value at the midpoint is greater than 6, so now I've got to shift the right over, which is mid minus 1. So then R becomes 4, L becomes 4, stays at 4, and we have the R answer. So we're going to do something similar to that. There's a few gotchas. The square root of 0 is 0, and the square root of 1 is 1. So if the number is less than 2, we're just going to return the number. And the only other thing that's slightly different is for the midpoint, we're going to actually multiply it by itself because we're looking for the square roots. We're looking for a number times itself that equals the input value. So let's jump into the code. If x is less than 2, just return it. We're going to define a long of number. So we do the midpoint times the midpoint, which are both integer. It could result in a number that doesn't fit in an int. So we're going to put that into a long. And then we have the midpoint. We're going to start the left at 2 because anything less than 2 we're just returning. Now the right is interesting. Let's say the number is 8, the input is 8. So we're going to loop through 2, 3, 4, 5, 6, 7, 8. But the number 8, or anything in the larger half of that set of numbers, will never be the square root. So you can automatically have the set of numbers for the right. So while left is less than or equal to right, we're going to assign the midpoint left plus right divided by 2. And then we're going to take the midpoint times the midpoint, convert that to a long, and stuff it into num. And this is what we're going to use for our comparison. So if num is greater than our input, then the right equals mid minus 1, meaning the number that we multiplied mid by is greater than the input. Else if the number is less than x, then the left is too small, and so we need to assign that to the mid plus 1. And if neither one of these cases are true, then we found the number and we just return the mid. So this works for every case where this works while left is less than right. So if left becomes greater than right, then means we passed over the number and we're just going to return the right. So let's jump into IntelliJ and run this. So I picked 8, the second example in LeetCode. So left is 2 and right becomes 4. Left is less than or equal to right in this case. So we assign the midpoint, which ends up being 3, and 3 times 3 is 9. So if number is greater, 9 is greater than 8, so then that means the right value, we need to bring that down. So we do that, and now left is 2 and the right is 2. And the mid is also 2. 2 times 2 is 4. So if number is greater than x, no. Number is less than x, that is true. The num is 4 and x is 8. So now we've entered into the case where left is actually greater than the right. So we passed over the answer, so then we just return the right, which is 2. Now let's throw this in LeetCode and see what we get. Accepted, no surprise there. I obviously run these beforehand to make sure they work. And submit it. So faster than 99.99. Ooh, there's just one out there that's faster. And 36.3 megabytes, less than 45%, so middle of the road. Last thing I'll go through is the space and time complexity. So time complexity is O log of n. Basically, we're having our data set after every loop. And then the space complexity is O of 1. We don't have any additional data structures, and we don't have anything inside the code that would increase the value of x. And that is all I have. So thank you again for watching, and let me know if you have questions. And I'll see you next time.